Ah, happy Valentine's, everyone. Yes, what am I doing?
The whole page.
Say it again.
The whole page.
You mean the classwork? Okay, so you had the pinkish.
Yep.
Okay, so we did this problem in class. What do we do with 4 terms? One more time. No. What do we do with 4 terms?
Substitute for another term?
With 3, if it's quadratic in form. What do we do with 4 terms again?
Oh.
Grouping. So I factor out x squared. And I get x plus 2. What do I have to get from the other 2? Otherwise I can't continue. No. I have to get in parentheses. I have to write it first, because then if I do write 9, I mess it up. So what do I have in here?
X plus 2.
Right. Now I look. Only now I look. What do I have outside? I need yes. So then I pull out what? The common factor, which is?
X plus 2.
Yes. And what is left in parentheses?
X squared minus 9.
We have a contract on x squared minus 9. It sounds like we're going to terminate x squared minus 9. We have a contract on x squared minus 9.
X squared plus 2x.
No.
X minus 3x.
Yes. How many solutions did you expect from the very beginning?
3.
Yes. How many solutions do we got?
3.
And they are?
-2, 3, -2.
Very good. And the 2x plus 6 divided by 3, I have to move 1 to the other side. You cannot distribute, simplify, multiply. You can't touch this. If you need to write it down, you can write untouchable.
Greater than 1.
I have to clean it up by adding 1 to both sides. Untouchable. If you don't remember how to change this into something that can be solved, we cannot solve it. What is it? There are 2 options here. What are the options? 2x plus 6 over 3 to be
Greater than 2.
awesome. And the other option?
Less than -2.
Very good. Okay? Can you take it from here? Or you need me to finish it up? Tim, is this clear?
Now it is.
Awesome. Good. Anything else? Yes, Kelsey?
Can you go over number 2 on the white one?
Yes, what does it say?
4x squared.
It's the same thing. It's the same thing.
No, I got that. I got it.
Okay.
I just got one of my answers.
So 4x to the third minus 12x squared minus 9x plus 27 equals 0. 4 terms. What do I do with 4 terms?
So
Right.
4x squared,
Very good.
x minus 3, minus parentheses, then minus 9, and then x plus.
So then I factor out x minus 3, and I get 4x squared minus 9, and I get x minus 3. We have a contract on 4x. We are terminating a lot of binomials in this class. 2x minus 3, 2x plus 3, and you get 3 options. You get x equals 3, x equals 3 over 2, and x equals negative 3 over 2. Anything else? Other questions for me? Anything else? Everything is going to be posted.
How do you get to the posted corrected answers?
Say it again.
How do you get to the posted corrected answers? Online.
Everything is in a folder. It says 2018, spring 2018. And I have to get, I'm waiting for this to end. So here's your course. I highly recommend redo every problem we covered in class. Every problem, okay? So here it is. Spring 2018 video lectures and lecture notes, everything, everything. Classwork, solutions version 1, version 2, and I'm going to continue posting them. And this is what we covered last time. graphing piecewise defined functions, more piecewise defined functions. We talked about the difference quotient. We applied it to different functions. Another function with a difference quotient. Then we talked about slopes, slope-intercept form, point slope form, parallel lines, perpendicular lines. Find the equation of a line and that is parallel, and so on and so forth. And Chip asked me, what is this? And I explained that this is not very useful. Any questions? I'm trying to see if it's done. Any questions for me? Any questions?
I have a question.
Yes.
So, when you, with the piecewise
Yes.
defined function, when we have the numbers that we're plugging in here, can you go over, like, even if it's the one we see in class, we have the numbers.
Yes.
Go over this one more time, I did not get this.
How we pick the numbers?
Yeah,
Anything between -3 and -3. I could pick -1,000, but I will not be able to plot that.
Yeah.
So I picked -4.
when you just graph it as you're going.
That's right.
Okay.
So -4 comma -2 is this point, but -3 comma -1 is this open point because of the parentheses.
Yeah.
And then -3 comma 1 is this point. It's a full point because there is a bracket. And then 0, -2 is this point. There's another
Gotcha.
bracket.
So we're just graphing it.
Yeah. So this is the previous test 2 that we will go over partially, hopefully today, and the rest next time. And I also have from chapter 1, I copied for you another.
So what is this? Just a review.
Previous, no. Do not look at it as a review because we may have something done in class that may not be there. It's not a review. It's something we are going to work on in class.
So this is,
So something that is not here and was done in class may still be on your test.
okay.
So this is something that happened last semester.
What
As
is
you
thing?
see on the pink form, it says 145. On this form, it says 141. It's the same course. We're just every now and then change names. It's the same material, no matter how we want to call it. Okay, so we are trying to finish the material tonight and then start working on this in class. Okay, anything that you have for me? Anything? 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 Okay, so in that case, we're going back to working on more problems from lines, which are found in 2.3 and 2.4. We have not gotten the chance to look at the average rate of change. So this is what I need to show you, the average rate of change today. And the long list of basic functions and then transformations. And that will be the end of the material for test 1. So we can start reviewing, okay? So one more time, anything you would like me to go back to? I will talk about those 2 forms. When we finish this, I'll tell you more about them. Okay? Shannon, can you wait for a second? Sorry. No problem. So I gave this out and I gave a copy of this and this and a copy of this. I'll tell you what we do
Thank
with
you.
this in a minute. Okay. Or 2, or 3, or 4, yes. Okay. If you remember, a while back, I don't remember if it was Monday or Wednesday, We looked at what it's called the different. No, it actually was Monday. I remember now. We looked at something called the difference quotient, right? And we said this was point A and this was point B. And now I'm going to say that this is x1. So this is the function f of x. So if this is the coordinate of A is x1, what will be the y coordinate of A? Yes, or exactly f of. Very good. Awesome. Thank you. So here's my x1, and here is, of course, f of x1. Good. So then I'm going to call this x value x2. So obviously this will be f of x2. So this is x2 comma f of x2. I would like you to give me the slope of the line passing through these points. That is also, so the slope AB is the same with the average rate of change of f of x between what? Of course, thank you. The average rate of change of function f of x between points A and B. So therefore equals. Can anyone dictate? Very good. Very good. Yes, but this time the difference between them is not age, it's just x1 and x2, so it's going to be x2 minus x1. Very good. Awesome. Say it again. Okay, Kathy?
That's the whole formula.
That's the whole formula. So the average rate of change of this function between A and B is nothing else but the slope of the line between those 2 points. So I drive to New York, and you call me, and you say, please tell me what is your speed. This is the instantaneous speed. I'm going to read it from the odometer. I'm going to say I'm driving at 62 miles per hour. But if you ask me, what is your average, what was your average speed between 2 points, then I have to do this.
Or you could just answer sufficient.
I guess so. Okay, so that's the average rate of change. Good. Let's work on a problem. I'm looking at problem 16 on page 279. We are given a function, f of x equals x squared minus 2x, and we are given x1, which is 3, and we are given x2, which is 6, I believe. Yes, 6. Here is what we are asked to do. Question. Find the average rate of change of the function from x1 to x2. So how do I address that issue? What do I have to do? Awesome. The corresponding what exactly? The corresponding, not points, but the corresponding y values. Yes. So I have to find f of x1, which is f of 3. Can anyone give us f of 3? Minus? Perfect, which is?
3.
Awesome. So now I need to find f of x2, which is f of 6. Can anyone give us f of 6? Minus?
12.
Yes, 36 minus 12 is? Good. So therefore, I want now to find the average rate between x1 and x2. You can write it like this, or you can write the average rate between 3 and 6.
7.
Yes? Shelby is way ahead of everyone. I have a student in another class who answers literally before I finish my question. So I have to start the question like this. Anyone except Tom. And then I ask the question because he's so fast. Okay, so then can anyone dictate step by step before Shelby got to the 7?
24
Over.
6.
Very good. The top is 21. The bottom is 3. The answer must be 7. I want to caution you on something. When you call me and I say, and you ask me, what is your speed? I know you're driving to New York. What is your speed? And I say, oh, my speed is 60 miles. Is that correct? No. It's a rate of change of distance at the top fraction with respect to time. So the distance is measured in miles. The time is measured in hours. So I would say I'm driving at 60 miles per hour. What I'm saying here is every time you're asked to determine the average rate of a change of a function, and you are told the function represents volume and the independent variable represents time in seconds, then the answer would be 7 cubic inches per second. So remember the average rate of change, or the slope for that matter, if the two variables represent a real life situation, this number will have a measurement unit composed from two pieces. The measurement unit coming from the top, slash or per, the measurement unit coming from the bottom. Clear? Okay, good. So we did a problem with parallel perpendicular. I remember that. And I think I'm in the situation in which I can finalize section 2.7. This is the last section before we start reviewing for the test. Our test is scheduled for a week from today. So I'm hoping that the second half today we review for the test, and also Monday whole day. Okay? So 2.5 transformations. Before we talk about transformations, transformations mean nothing if we do not remember what it's called basic, what I like to call basic functions. For each category of functions, there is what it's called the basic function, the simplest possible function in that category. Okay, so let's start with linear. Can anyone give us the simplest possible linear function? There
X
is.
equals 7.
F of x equals? That is true. Tim is right. So that is a horizontal line that is y equals 7. But who really cares about it? Me too. I have to take its side as well. So, okay, we do care about that, but it's not the simplest possible function. That is linear. The simple linear function would be f of x equals?
0.
Not the domain. We're talking about how will the simplest possible linear function be expressed. Simplest possible. But that is the same thing. It's just as like saying that this is absolutely. That is the simplest possible linear function. There is nothing easier than this. Very good. And this is a line that bisects two quadrants. The first and the third. Here it is. We have to graph it. So here's the graph of f of x equals x. Odd, even, or none of the above? Even means symmetric with respect to the y-axis. Is this graph symmetric with respect to the y-axis? No. So it's not even, but Because it's symmetric with respect to the origin. Very good. I would like to get the simplest possible quadratic function. Simplest on the planet. F of x equals x squared. There is no simpler quadratic function than this one. Very good. Okay, so let's graph it. We know the graph, 1, 1, 2, 4, and so on and so forth. We remember that. So here it is. So this is f of x equals x squared. Odd, even, or none of the above? Thank you very much. Perfect. Next. F of x equals f of negative x equals f of x. It's symmetric with respect to the y-axis. Yeah, a while back we looked at two different graphs. This was one of them. When f of x equals f of negative x. The other one is the opposite. F of negative x equals negative f of x. That would be odd.
So how do you, odd is the direction?
Odd is symmetric with respect to the origin.
So it's going up, so it's even?
Even means symmetric with respect to the y-axis. Odd means symmetric with respect to the origin. So what I have here, I have a copy here across the origin. What I have here across the y-axis, which is even. And the relationship, one more time, is for odd, f of negative x is the opposite of f of x. We proved this some time ago. And for even, f of negative x equals f of x. We'll go back and review that. Absolute value. Can anyone give us the simplest possible absolute value, the basic absolute value function? What is it? Of course. So here's the graph. Anyone remembers how to graph the absolute value of x? Perfect. So it's right here, it bisects this first quadrant and the second quadrant. So this is f of x equals the absolute value of x. Odd, even, none of the above.
Even.
Absolutely symmetric with respect to the y-axis. Very good. Square root function. Anyone remembers the simplest possible square root function? There is no other radical function, square root function, that is easier than this one. Of course. What is the domain? How do I write it? So in my little notebook that I kindly ask you to, especially now when you're starting reviewing for the test, I would write in my notebook, how do I determine the domain of a square root? Oh, I have to do this, and I have to solve it, and then I have to write blah, blah, blah. How do I find the domain of a square root? What do I have to write? That the quantity under the square root, that's it. So the domain of this function is 0 to infinity. For some reason, the square root function is not liked by many. I don't know why. I like it. Ready?
I don't, because it reminds me of division. I don't like division.
Not sure how we connect that to division.
Division.
I don't see it, but that's okay. Tim, are you okay?
Maybe.
Odd, even, or none of the above? Exactly. Or in other words, I will write not symmetric. That's what it means. Odd even means symmetric, either with respect to the y-axis or with respect to the origin. Cube root?
What about the range? Do we worry about the range?
No, not at this point, but if you want to edit here, the range is still 0 to infinity. Yes. Very good. Can anyone give us the simplest possible cube root function? Good. I want the domain also here. Only because I would like to refresh your memory on this, that's all. What is the domain of the cube root? Can I plug in -8?
Yeah, because it's the odd.
Exactly. So what is the domain? Because the index is odd, the domain is
Negative.
awesome. I didn't torture you in the previous class for nothing. Good. Awesome. Thank you, Reese. Good. So it's defined everywhere. Here's the graph. We have to remember this graph. It's similar to the square root, but not really. Here it is. So this is the graph of the cube root of x. One more function. But before that, odd, even, or none of the above. Of course. Symmetric with respect to the origin. And the last function, rational function. This was not really discussed in the previous course. It will be extensively discussed in chapter 3, but we have to add it to the list now of basic functions. Can anyone give us the simplest possible rational function? Okay, let me rephrase. Can anyone give us the simplest possible rational function, please? My apologies. We know how rational equations look like. We should be able to know how to present the simplest possible rational function. Kathy? The square root is not part of a rational. It's a combo of rational and blah, blah, blah. But I want just the simplest possible rational. Absolutely. 1 over x is the rational, simplest possible rational function. Very good. Can anyone give us the domain of this function, please?
It has to be greater than 0. So.
Let's think. Let's think. This is not like the square root. What can go wrong here?
It can be 0.
Just 0 can go wrong. Yes. That's the only problem. That's it. The denominator can be a negative or positive number, but it cannot be 0. Very good. Let's graph this function. You have to trust me on this function because, as I said, we're going to come back extensively on this in chapter 3. So now please trust me with the graph. Okay? Just for you to see it the first time. Here's the graph. It does not touch the x and the y axis. So this is f of x equals 1 over x. Odd, even, or none of the above. Very good. Symmetric with respect to the origin. Okay. Now, we have to remember these graphs. Without these graphs, transformations mean nothing. Question. Can I do very well in any math course without knowing transformations? Yes. Is it good to know transformations and understand the function? Decompose it in parts? Yes. Yes. I don't know what he said, but whatever he said is no. So it is a very useful skill. Can I succeed in math without factoring? Of course. But it's a very important skill to have because you'll be able to solve equations if they're factorable, right? So let's analyze transformations, and you will see it in the next probably 20 minutes or so. You are going to understand a lot about a function by simply looking at it, not doing anything. Okay? So at some point in time, I'm going to put a function on paper and say, just imagine, and you will tell me exactly how the graph is looking like. It looks like. But, don't forget what you want to say, but not without knowing these graphs. It's not going to happen. Without knowing these, transformations mean nothing. Reese, please.
So transformation is that just when it just moves left to right or up and down?
That's it. That's it. There are 3 different types. So let's start. Transformations. 3 different types. In other words, we take a basic function and we create a complicated one out of it. And we want to know the steps. We will learn a lot about the function by knowing how we get from the basic function to a new function. And how many steps are in between. Exactly. Transformations, 3 types. Shifts, reflections, the last one is stretching, shrinking. Shifts are of 2 types, horizontal and vertical. So horizontal and vertical. Reflections of 2 types, WRT with respect to x-axis, y-axis. I'm not talking about symmetry here. And we don't have symmetry with respect to the x-axis. So WRT with respect to. So reflection with respect to the x-axis and with respect to the y-axis.
Is that negative X?
No, it's just a
Oh, okay.
Oh, okay.
and stretching or shrinking, of course, horizontal, vertical. So let's start with shifts. I want to say that from all these transformations, 1, 2, 3, 4, 5, 6, everything will be straightforward except this one. Okay? That one is the most unusual, if you want, or it's everything else will be exactly what you expect to happen, but that one will not be exactly what you expect to happen. So I'm going to leave that for the last. Okay, shifts. Let's say I want to create, I'm going to call these functions f1 and f2 all the time so that there is a difference. So you know there is a difference between. So f1 of x equals x squared plus 4. And f2 is x squared minus 3. Which base function or basic function was used in creating f1 and f2? The absolute value? No. The square root? No. A rational function? No. Specifically, which one? Right, of course. So now if I graph x squared, this is what I see. And now let's look at x squared plus 4 and analyze what changes here. So there are 2 possibilities. When I compare this to this, I can see a change in x or a change in y. So x squared stays as s squared. There is no change in x. X squared is identical, it has not changed. What changes? This is x squared plus 0. Yes, Marcus?
Oh, but actually that's the question.
Go ahead.
It just goes up 4.
Yes. So this is x squared plus 0, and this is x squared plus 4. Where will this graph f1 go?
Shifted.
That's it. So it's a vertical shift of 4, up 4. So 1, 2, 3, 4. I just copy the graph. So this is x squared plus 4. I'm going to say in parentheses, up 4. Now what changes in f2?
It goes down 3.
Right. Which function? The base function, not the blue function that we just graphed. That's why I want you to see the difference. So this is not related to that. This is related to x squared. This was x squared plus 0, and this is x squared minus 3. So obviously this function shifts the basic function down 3. So this is x squared minus 3. Any questions here? So in parentheses, I will write down 3. So this was a horizontal or a vertical? Was it a change in x? When I change x, I move horizontally. When I change y, I move vertically. So is it a vertical shift or a horizontal shift? So this is done. Okay. I'm going to create 2 new functions. Here is f1, which is the absolute value of x minus 3. And this is f2, which is the absolute value of x plus 4. Which basic function was used in creating f1 and f2 this time? Square root? No. Cube root? No. But, of course. So the base function is the absolute value. So this is the absolute value of x bisecting the first and the second quadrants. Now I'm doing my analysis. What am I changing? Am I changing x or am I changing y? Because if I'm changing x, you will tell me something like this. If I'm changing y, you will tell me something like this. Which one is it? I'm changing x. From x to x minus 3. Do not conclude just yet. Hold on for a second. This, when x is 0, y is 0, correct? So this will have this vertex, if you want. It's not called vertex, this sharp, the corner. So y is 0, the function is 0 when x is 0, correct? Where is this function 0? When x is, aha. Now you tell me, where does this go? Does it go to your right or does it go to your left? Of course. So you probably wouldn't expect this, but x minus 3 shifts the graph to the right 3. Because when is this 0? At 3. When is this 0? At 0. So the new graph is completely parallel to the shape of this graph. So parallel here and parallel here. So this is the absolute value of x minus 3. Now let's analyze f2. What changes here from the absolute value of x to the absolute value of x plus 4? What changes? So does the graph move left and right or up and down?
Left.
Yes. Why does it move left? Hold on. So this is 0 when x is 0. When is this 0? When x is negative 4. Therefore, so let me write here, right 3. And here I should write left 4. So here's the graph. 1, 2, 3, 4, completely parallel to the blue graph. So the absolute value of x plus 4. So when we change x, we're talking about horizontal shift. When we change y, we're talking about vertical shift. Is that clear? Okay, so this was a horizontal shift. Perfect. Okay, reflection now. So I want f1, the square root of negative x, and I want f2, negative the square root of x. So let's think about this, and I would like to ask, like before, which base function did we use now? The cube root? No. 1 over x? No. But the square root. Very good. So the base function is the square root. I'm going to graph it. Here's the square root. Now I have to be very careful. Again, the next step is the same analysis. What am I changing? So don't answer just yet. So I see here the square root of x. But in here, I have the square root of negative x. So what changes? X or y? X. From, follow me for a second, from positive x to negative x. So what type of transformation is this? With respect to the y-axis. So reflect with respect to the y-axis. I'm reflecting. Here's my reflection. It's never perfect on this side. For some reason, I can't do it absolutely perfectly. Sorry about that. So this is the square root of negative x. Agreed?
Mhm.